We will now understand the divisibility of composite numbers. Okay, so let's say I take a composite number 15. Okay, for composite numbers, it's very simple if you understand the basics. Okay, for composite numbers, let's take the example of 15. Okay, now write 15 is a product of two numbers which are co-prime, means each other. That means having nothing in common. Okay, so I write 15 as 5 into 3. Okay, so a number which is divisible by 5 and also divisible by 3 will be definitely divisible by 15. Okay, this you can basically split for all composite numbers out there. So for example, if you take 24, 24 in two co-primes will be 4 and 6. No, 4 and 6 में 2 is common. Not correct. Okay, you can take 3 and 8. Okay, so अगर number 3 से divisible है और 8 से भी divisible है, then it will be divisible by 24 also. Okay, let's say 144. Okay, 144 will be slightly tricky if you don't know tables, but if you know it is 16 times 9, right? So अगर number 16 से divisible है और 9 से भी divisible है, number 144 से भी divisible होगा. Okay, let's take a number like 1729. What is 1729, guys? It is the Ramanujan number. Okay, very interesting number. इस पे एक अलग से I'll make a bonus video, so do check it out. It's very amazing. 1729 is basically 7 into 13 into 19. Okay, so अगर number 7 से divisible है, 13 से divisible है, 19 से भी divisible है, तो वो Ramanujan number, the smallest Ramanujan number 1729 से भी divisible होगा ही होगा. Okay, so I hope the concept is very clear. Now we'll solve some questions now and try to understand how do we apply these concepts into questions. So yeah, find whether the following statements are true or false. The first question is 9867511432 is divisible by 24. Okay, just now we saw that divisibility of 24 means the divisibility with 3 and 8, two co-primes. Okay, now क्या ये number 8 से divisible है? Okay, for 8 is basically 2 raised to 3. So we check the divisibility of the last 3 digits. Okay, so 432, it is divisible by 8. Yes, it is divisible by 8. 8 5 is 40, 8 4 is 32, right? So ये number 8 से divisible definitely है. अगर ये 3 से भी divisible हुआ, तो ये number 24 से divisible हो जाएगा. Okay, you can add them all, or you can observe. If you add the numbers, you get sum of the first 9 natural numbers. इसका एक shortcut है, आगे जाके हम सीखेंगे sequential series में. Okay, summation of the first 9 natural numbers is 9 into 10 by 2. Basically, summation of first n natural numbers is n into n plus 1 by 2. So basically ये हो जाएगा 9 into 9 plus 1 by 2. ये आता है 45, जो कि 3 का multiple है. तो ये number 3 से भी divisible है. Since ये number 3 और 8 दोनों से divisible है, the number is also divisible by 24. Okay, so statement is true. All right. Same way, 990924 is divisible by 66. 66, guys, into two co-primes, you will split it as 6 and 11, right? 6 11s are two co-primes. Also, 6 can be further split as 2 and 3. So, ये number 2 से 3 से 11 से तीनों से divisible होगा, तब जाके ये 66 से भी divisible होगा, right? So, checking the divisibility with 2, it's an even number. Of course, 4 से end हो रहा है, it's an even number. So, it's divisible by 2. Okay, checking the divisibility with 3, take the sum of the digits. Okay, now guys, the interesting part here is जितने भी 9 होते हैं, whenever we add the digits, don't take the 9s into consideration because 9s do not change the sum. For example, if you add 2 may 9, 2 plus 9 is 11, 1 plus 1 also gives you back 2, right? If you take 3 plus 9, 3 plus 9 is 12, 1 plus 2 again gives you 3. So whenever you find the sum of the digits, ignore the 9s in the sum because 9s will not change the sum. Okay, बचा क्या? 2 and 4. 2 plus 4 is 6. It's a multiple of 3. So a number also is a multiple of 3. Now checking the divisibility with 11, starting with the last digit 4. 4 plus 9 plus 9 is 22, right? And the remaining digits 2 plus 0 plus 9 is 11. 22 minus 11 is 11. Difference is 11. That means number is also divisible by 11. Abhi number 2, 3, 11 in तीनों से divisible. That means the number is also divisible by 66. So statement is true. Let's go on to the next part now. Okay, the next question. Given that 8A5146B, where A and B are digits, single digits, is divisible by 88, then find the value of A raised to B plus B raised to A. Okay, so अगर ये number 88 से divisible है, I can split 88 as 8 times 11, right? अब अगर ये number 8 से divisible है, we first find out the last 3 digits. okay, 46b, अगर 46b 8 से divisible है, okay, you can check by putting b is equal to 0. If you put b is equal to 0, it becomes 460. क्या 468 से divisible होगा? Okay, let's check. 460 divided by 8. Okay, 8 5s are 40, 8 7s are 56. नहीं, divisible नहीं. You are getting a remainder 4, right? That means b cannot be equal to 0. अगर b 0 लिया तो I am getting a remainder 4, जबकि number 8 से divisible होना चाहिए. So last 3 digit भी 8 से divisible होने चाहिए थे, right? If the remainder is 4, very smartly you can say you take b as 4. So the number becomes 464. And now in that case, it won't give you any remainder, right? So very smartly, you can figure out the value of b, okay? And that is equal to 4. Once you figure out the value of b, the game is half over. Right? So now the number becomes 8a51464. अब ये number 11 से भी divisible है. So we check the difference of the alternate places, right? Difference will be 4 plus 4 plus 5 plus 8. 4 plus 4 is 8, plus 5 is 13, plus 8 is 21. Right? And the remaining places are 6, 1 and a. 6 plus 1 plus a is 7 plus a. Okay? इनका डिफरेंस या तो 0 आना चाहिए या फिर 11 का मल्टीपल आना चाहिए. Okay? Very smartly you can observe that for the difference to be a multiple of 11, it can't exceed 21, right? Because 21 minus something, okay, even that thing is positive. अगर 0 भी होगा तो 21 के आसपास जाएगा. Okay, but if this part is positive, okay, अगर ये part positive भी है, 21 minus something positive will be definitely less than 21, right? So 22 के आगे check ही नहीं करना है basically. So difference can be either 0 or a multiple of 11, right? So 21 minus 7 plus a, अगर हम first case लेते हैं, is equal to 0, I'll get a is equal to 14. Impossible, because a is a single digit. As per the question, a and b both are single digits, right? The next possibility can be 21 minus 7 plus a being equal to 11. If that is the case, 7 plus a is equal to 10 or a is equal to 3. हाँ, ये एक possibility है. In fact, ये एक ही possibility है for the value of a, because the difference can't be now 22, 33 and so on, right? So we found the value of a as equal to 3, right? अब उसने क्या पूछा है? a raised to b plus b raised to a. So they are asking us 3 raised to 4 plus 4 raised to 3. 3 cube is 81, 4 cube is 64. Your answer is 145. All right, guys, so we are going to the next and the last question for divisibility. And it says, can there be a perfect square made of 4 ones, 4 twos, and 4 zeros written in any order? Okay, पहली बात तो ये बताओ कि ऐसे कितने नंबर बन सकते हैं 12 digit numbers which consist of 4 ones, 4 twos, and 4 zeros. Don't worry, we'll discuss this question when we study permutation combinations. Okay, right now it is the divisibility aspect that basically interests us. So can there be a perfect square made of 4 ones, 4 twos, and 4 zeros written in any order? Okay, now order कुछ भी हो, okay, ultimately हम लोग क्या लिख रहे हैं? We are writing 4 ones, we are writing 4 twos, and we are writing 4 zeros, right? अब भले नंबर पता ना हो, but हमें उस नंबर का sum of the digits पता होगा, right? Because since we do not know the actual sequence of the digits, but we know what are the digits involved, right? So we can just add the digits. When you add all these digits, you'll get 4 ones, 4 twos, 4 zeros. 4 plus 8 plus 0 will be 12, right? Now we have a small problem. अगर ये नंबर का sum of the digits 12 है, तो ये नंबर 3 से डिविजिबल होगा, बट 12 इज नॉट अ मल्टीपल ऑफ 9, मतलब ये 9 से डिविजिबल नहीं होगा. नाउ गाइस, isn't this a contradiction? See, if I have a perfect square, let's say 9, okay, or let's say 36 for that matter, or you can also take the number as let's say 441. All these multiples of 3 are perfect squares, but they are not divisible only by 3, they are divisible by 9 also. Why? Because since they are perfect squares, they will have to have 3 in the form of 3 square or 3 raised to 4 or whatever, right? So any perfect square which is a multiple of 3 should also be a multiple of 9, which is a contradiction here. It's not happening here, right? That means no such perfect square is possible, which is made of all these digits, 4 ones, 4 twos, and 4 zeros. Okay. Now there is a much easier approach for this question. If you don't want to get into divisibility, there is a common sense based approach for this question I will suggest. So let's observe perfect squares. Perfect squares may we take the first perfect square is 1 square, which is 1. 2 square is 4. 3 square is 9. 4 square is 16, 5 square is 25, 6 square is 36, right? So if you observe carefully, the sum of the digits of these perfect squares is either 1, 4, 9 or 7 always. Okay, you can take any perfect square in the world. Okay, add the digits. The sum of the digits will always add up to give you 1, 4, 9 and 7, right? But in this question, the sum of the digits of the perfect square, okay, and that is 4 ones, 4 twos and 4 zeros. Okay, you add all these digits, right? 4 ones, 4 twos, 4 zeros. The sum basically comes out to be 12. Not possible, right? So since the squares of like natural numbers, perfect squares are always having the sum 1, 4, 9 or 7. Okay, you can never have a perfect square like this. 4 ones, 4 twos and 4 zeros. That's it for this class, guys. And we'll meet you in the next lecture. Bye-bye.